Hello friends, in this video I am discuss about time independent perturbation theory. Consider an unperturbed Hamiltonian H0 such that it act on unperturbed state psi 0, we will get En0 psi n0. Now perturbation coming means H0, now it become H, which is equal to H0 plus H dash. Okay, this H dash is perturbed Hamiltonian. Perturbed Hamiltonian, and this is unperturbed Hamiltonian, and this is total Hamiltonian. Okay. So now H is psi, which is equal to En psi. Now this En will be En0 plus En of 1. This is first order correction in energy. This is first order correction in energy. Okay, so our task is find out En1, that is first order correction. The formula, we are not going to the derivation part, we are directly giving the formula, then we will illustrate by an example. So formula to find first order correction in energy is nothing but psi n0, the unperturbed unperturbed wave function psi n0 h dash psi n0. Okay, this is perturbed Hamiltonian. Okay, this is the equation. Okay, now we are taking one example. Example is this harmonic oscillator. It is given that perturbed Hamiltonian is given half bx square. We know H0 unperturbed Hamiltonian is we not need H0 here. We need to find En1, that is first order correction, which is equal to psi n0 h dash psi n0. Okay, this h dash is given, which is half bx square. So our perturbed Hamiltonian is half bx square. So in linear harmonic oscillator, in psi n0 is ket n. So we need to find first order correction En of 1, which is equal to ket n h dash ket n. Okay, h dash is half bx square, so half be taken outside, ket n x square ket n. We know that in harmonic oscillator in quantum mechanics, x is root h bar by 2 m omega a plus a dagger. Here a is lowering operator and a dagger is rising operator. Means a acts on ket n, we will get ket root n ket n minus 1. So this is called lowering operator. And a dagger act on ket n, we will get root n plus 1 ket n plus 1. So this is called rising operator. And also this is x, and x square is h bar by 2 m omega a square plus a dagger square plus 2 a dagger a plus 1. Okay, so substitute this here, we will get half b h bar by 2m omega, then get n a square plus a dagger square plus 2 a dagger a plus 1 get n. Okay, so which is equal to half and a half become this 2 to 4, then b h bar by 4 m omega. Okay, this thing is here, and now we will write it separately like n a square n plus n a dagger square n plus 2 taken outside n a dagger a n plus get n n. Here remember one thing, get n, get m, inner product of n and m is delta nm, delta mn, which means that which is 1 when m equal to n and which is 0 when m not equal to n. That is orthogonal. The states are orthogonal. Okay, so for example, get n minus 1 should be 0. Similarly, n plus 1 should be 0, because this, let's say this is m and this is n, which are not equal, so we can easily say they are 0. This is 1. Okay, because n equal to m. This is called orthogonality condition. Okay, remember this. Also, we know that a axon ket n is root n minus 1. So we will use these two and apply this here, and then we can write this as b h bar by 4m omega, and here it become a axon first a axon ket n become give root n into ket n minus 1, then a axon ket n minus 1, then it will give n root n minus 1 ket n minus 2, then finally it become ket n minus 2. Similarly, add another axon ket n which will give coefficient root n plus 1 and eigen ket n plus 1, then again add another axon ket n plus 1 which will give coefficient root n plus 2 and ket n plus 2, then finally this one. Okay, then here a axon ket n first, then it give a coefficient root n and eigenstate ket n minus 1, then a dagger axon ket n minus 1 which will give a coefficient of root n minus 1 plus 1 and effectively eigenket is root eigenket is n, means ket n minus 1 plus 1 plus 1, which is effectively ket n, because plus 1 minus 1 will cancel. Okay, so here we can write ket n and plus this obviously 1. Okay, this is 0 and this also 0, because n and m are not equal to 1, but this is 1. Here root of n minus 1 plus 1 minus 1 plus 1 will go, it effectively give root n into root n n. So this become b h bar by 4m omega. This will give 0 0, here root n into n. There is a 2, there is a 2, because this 2 should be appear here, so it become 2n root n n, this 2 here plus this 1 here. Okay, so this is the final answer, b h bar by 4 m omega into 2n plus 1. This is the final answer, first order correction in energy. So final answer is this, En of 1 first order correction in energy is b h bar by for m omega 2n plus 1. Okay, I hope it is clear to you. If you have any doubt, then please ask in the comment section. Thank you. If you like this video, then please share to your friends and subscribe to this channel.